Can you see the screen? Problems on beta and gamma function. Can you see the screen?
Yes, ma'am.
Yes, ma'am.
Okay. Yes. So in our last class, we had a definition on beta, gamma and beta functions, and we discussed some properties in our last class. So at first, let us have a review on our knowledge of beta and gamma function. So here you see, this is the definition. In number 1, it is the definition of gamma function. Gamma n equals to integral 0 to infinity x to the power n minus 1 into e to the power minus x dx. Here, this n should be a positive number. This n should be a positive number. Remember it. Gamma of a negative number is undefined. Okay. So here, x to the power n minus 1 into the power minus x. Here, n is a positive number. Next property. Gamma n plus 1 equal to factorial n. At first, actually, this property should be written in number 2. Gamma n plus 1 equal to n into gamma n. Gamma n plus 1 equals to n into gamma n. So, gamma n can be written as gamma n plus 1 divided by n. And this should be the third property. If n is a positive integer, in that case, gamma n plus 1 will be equal to factorial n. Now, it can be, we have already proved this one, gamma half equal to root over pi. Gamma half equal to root over pi, it was proved in our last class, and this was also proved. Gamma 1 equals to 1, and we can easily show that gamma 0 equal to infinity using this property. You see gamma 0. Gamma 0 use just this property. Gamma 0 equal to gamma 1 divided by 0. Gamma 1 is 1 and n is 0. 1 by 0 is infinity. So gamma 0 equals to infinity. Now comes the beta function. This is the definition of beta function. Beta mn equals to integration 0 to infinity. In the definition of gamma function, the limits were 0 to infinity. But in the definition of beta function, it is 0 to 1. X to the power m minus 1 into 1 minus x whole to the power n minus 1. You see in the definition, in the value of this, it is gamma m gamma n. So you see this m and n must be positive numbers, positive real numbers. They cannot be negative. So in the definition of beta function also, you see this m and n, they should be positive numbers. It may be fraction, integer, but cannot be negative. Okay, this was the first property for beta function. Beta mn equals to beta nm. Same result will be coming if you write n in place of m and m in place of n. And this is a very important relation in between beta function and gamma function. Very, very important relation. Beta mn equals to gamma m into gamma n divided by gamma m plus n. And there was another result. We did it. All of these are done in our last class. Integration 0 to pi by 2 sin to the power p theta cos to the power q theta d theta equals to gamma p plus 1 divided by 2 into gamma q plus 1 divided by 2 divided by the whole thing divided by 2 into gamma p plus q plus 2 divided by 2. We derived this in our last class. And in the problems, we have done this one. Integration 0 to infinity, x to the power m minus 1 divided by 1 plus x to the power m plus 1. This is same as integration 0 to infinity, x to the power n minus 1 divided by 1 plus x whole to the power m plus 1. These two are equal, and this is another expression for this beta mn. It was done in our previous lecture. It is there in the previous lecture file. And this was actually not done, and we are not going to prove it. This is another important relation, but we are not doing the proof. Proof is complicated. You just try to memorize the result. Gamma p into gamma 1 minus p. Gamma p into gamma 1 minus p. That means this p must be less than 1. This p must lie in between 0 and 1. It cannot be 0, it cannot be 1. It should be a proper fraction, because if p is 0, gamma 0 is infinity. And if p is greater than 1, this expression will be negative, and gamma of negative thing is undefined. So this p must lie in between 0 and 1. That means this p must be a proper fraction. And this is the result. Pi divided by sine of p into pi. Gamma p into gamma 1 minus p equals to pi divided by sine of p into pi. So these are the results, definition, and the important properties. There may be more properties, but these are the gist. Doing math, these results are very, very important. So first math, integration 0 to infinity. Shall I make it the size? Shall I make it large? Now you can see. Integration 0 to infinity e to the power minus pt divided by root over t into dt. You have to evaluate this integral. You see, this is an improper integral. Without the help of gamma or beta function, it is very complicated to evaluate this integral. Okay, let us write it in this way. 1 by root over t, that means t to the power minus half. T to the power minus half into e to the power minus t. Now let us take a substitution. Suppose pt equals to x. Because we want to put it, since there is e, let us try to get an expression for that thing, gamma n. Okay, pt equal to x. So here t is a parameter. Remember, this t is the variable, and the substitution is x. For pt we are writing x, so p should be acting as a parameter regarding to these two variables t and x. So that means p should be treated as a constant. So if you take the differential, it will be p into dt equal to dx. Now take the limits. When t equals to 0, x should be 0. When t equal to infinity, x should be infinity. So there is no change in the limit. And in the next step, 0 to infinity, what should be the value of t? T is x by p. X by p whole to the power minus half into e to the power minus x dx by p. So you see, since this p is a parameter regarding to this variable x, we can take this p outside. So it is p to the power, in the denominator, it is p to the power minus half, and there is a p. So minus half plus 1, the power, it should be half. That means 1 by root over p. And what remains here? X to the power minus half into e to the power x. X to the power minus half into e to the power x. Now what was the definition of gamma function? X to the power n minus 1 under the integral x to the power n minus 1 into e to the power x. This part is okay, but here we have x to the power minus half. But this minus half can be written in this way. Half minus 1. This minus half can be written as half minus 1. So this half can be treated as our n, and it is positive. So the result should be 1 by root over 5 should be there, and for this integral the result should be just gamma half. This is our n. It goes to the formula 0 to infinity x to the power n minus 1 into e to the power minus 6 dx, which is nothing but gamma n, and here in place of n you have half. So gamma half, and we know the value of gamma half, it is root over pi. There is another root over p in the denominator, so ultimately it should be root over pi divided by p. So this is the answer. Next math. Here e to the power minus a x to the power m into x to the power n. Since there is e, so we will try to get an expression for gamma of something, because there is e to the power minus something. So what should be our substitution? Let us take a into x to the power m as y. X is already there, so you cannot take x. So now you take the differential, it should be a into m into x to the power m minus 1 into dx equal to dy. Now check the limits. When x equal to 0, y is 0. When x equal to infinity, y should be infinity. So there is no change in the limits. So it should be e to the power minus y. Now you have to find the value of x. You see from this expression, x to the power m equals to y by a. So x should be equal to y by a whole to the power 1 by m. X should be y by a whole to the power 1 by m. So x to the power n, it should be y by a whole to the power n by m. Okay. Now dx. What is the value of dx? Dx should be dy divided by a m into x to the power m minus 1. Now again you have to replace this x by what? Y by a whole to the power 1 over m. And here again the power is m minus 1. So the power to this y by a should be m minus 1 by m. Now let us do the simplification. Here m is a constant, a is a constant. So here in the denominator the power of a is n by m and here it is 1. So a to the power n by m plus 1. And there is 1 m here. So this part goes outside the integral and under the integral sign e to the power minus y into, in the upper side, y to the power n by m dy. And here in the denominator in place of x we have got y by a whole to the power m minus 1 divided by m. Now again you see in the denominator 1 over a whole to the power m minus 1 by m. That means it is 1 minus 1 by m. And it is in the denominator. So this a goes up. It should be a to the power 1 minus 1 over m. And here e to the power minus y to the power n by m into y to the power, it should be minus of 1 minus 1 over m. That means when you take it to the upper side, the sign will change and it will be minus 1 plus 1 over m, right? So this comes as the power of y. So ultimately there is a minus 1 and we just add this n by m plus 1 by m. That means n plus 1 divided by m. The power of y is n plus 1 divided by m minus 1 into e to the power minus y dy. So it goes to the formula, this formula. Gamma n equals to this. Here in place of n we have the variable y in place of x, and in place of n we have n plus 1 divided by m. So it must be gamma n plus 1 by m. And this is the thing coming as a constant factor. Okay. Now you see there is no e here, no e to the power something. So we can try to express this function so that we can get beta of something, beta function, because there is no e to the power something here. So at first we take a substitution x to the power 7 equal to something, x to the power 7, so that you see it will be like this, 1 by minus say y whole to the power minus half. So we can try for beta function anyway. So take the differential, 7 into x to the power 6, 7 into x to the power 6 dx equal to dy. So x dx, in the upper part you have x dx, so x dx should be equal to dy divided by 7 into x to the power 5. Now check the limits. When x equal to 0, y should be 0. Okay, there is a mistake here, it should be 0 here. When x equal to 0, y should be 0. When x equal to 1, y should be 1. So there is no change in the limit, 0 to 1. And here x dx means dy divided by 7 x to the power 5. This 7 is taken outside, and here root over 1 minus y. Now you put down the value of x. The value of x should be y to the power 1 by 7. So x to the power 5 should be y to the power 5 by 7. Now we take all these things from the denominator to the numerator. So the power of y is minus 5 by 7 and the power of 1 minus y is minus half. So this minus half can be written as half minus 1, and this minus 5 by 7 can be written as 2 by 7 minus 1, because we will have to try to get the expression for beta function. This is our beta function, integration 0 to 1 x to the power m minus 1 into 1 minus x whole to the power n minus 1, where m and n, both of them should be positive numbers, positive real numbers. So this minus half, you can write it as half minus 1, because minus 1 should be there. So here, if you write minus 1, it should be half. And here, if you write minus 1, it should be 2 by 7. So your m is 2 by 7 and n is half. So it goes to this formula, and the result is beta 2 by 7 half. There was a 1 over 7 outside. So this is the result. Now another math. Integration 0 to infinity t square dt divided by 1 plus t to the power 4. Here also you see there is no e to the power something. So we will try to get expression for beta function. So let us have this substitution. Suppose t to the power 4 equal to u. Because you see it will be 1 plus x, and when taken upper side it will be 1 plus x whole to the power something. Okay, we start with this. T to the power 4 equal to u, so 4t cube dt will be du. So the value of t should be u to the power 1 by 4. Now adjust the limits. When t equal to 0, u is 0. When t equal to infinity, u is infinity. Okay, and the value of dt is du divided by 4t cube. T is u to the power 1 by 4, so t cube should be u to the power 3 by 4. Now you put down the value t square. T square should be u to the power half. Yes, t square should be u to the power half divided by 1 plus u, and here dt should be equal to du divided by 4 u to the power 3 by 4. So what should be the power of u in the upper side? It should be u to the power half minus 3 by 4, right? And here du divided by 1 plus u. This 4 is taken outside. But here we are not getting the expression for beta function, because it is 1 plus u. How can you manage it? Let us have another expression, substitution. Suppose y equal to u divided by 1 plus u. Y equal to u divided by 1 plus u. So you try to get the value of u in terms of y. If you do the algebra, the value of u should be y divided by 1 minus y. So let us put it here. Here the power of u becomes minus 1 over 4 divided by 1 plus u. So the value of u is this. So it should be y to the power minus 1 by 4 divided by 1 minus y whole to the power minus 1 by 4. And in place of 1 plus u, u is this, y by 1 minus u and 1 plus u. If you add a 1 here, in the upper part y minus y will cancel out. It will be just 1 divided by 1 minus y. So the value of 1 plus u is nothing but 1 over 1 minus y. Now you do the algebra. It is y to the power minus 1 over 4, and here it should be 1 minus y whole to the power minus 1 over 4 minus 1. That means minus 5 by 4. If you take it to the upper side, it should be 1 minus y whole to the power 5 by 4. Now we are very close to the expression for beta function. Just to write the powers properly, you see here it should be 5 by 4. Okay, what is the value of du? We didn't write the value of du. Who is this? It is easy to find the value of du here. The du value should be equal to 1 minus 1 sign, so it should be plus 1 by 1 minus y whole square. The value of du is 1 by 1 minus y whole square. Yes. 1 by 1 minus y whole square. Okay, now you adjust the power of 1 minus y. So it should be 5 by 4 minus 2. And it gives you 5 minus 8 by 4. That means minus 3 by 4. Now adjust the power according to the definition of beta function. This minus 1 over 4 can be written as 3 by 4 minus 1. 3 by 4 minus 1, and this minus 3 by 4 can be written as 1 by 4 minus 1. So this 3 by 4 should be our m, and 1 by 4 should be our n. So there was 1 by 4 outside, 1 by 4 into beta, 3 by 4, 1 by 4. And here we can use the relation beta p comma 1 minus p. Because you see this 1 over 4, it means it is 1 minus 3 by 4. So it goes to the formula for beta p 1 minus p, which is nothing but pi divided by sine of p pi. Your p is 3 by 4. So it should be 1 over 4. The value of this integral should be 1 over 4 pi divided by sine of 3 by 4 into pi. This 3 pi by 4 can be written as pi minus pi by 4. So which gives you sine pi by 4, and sine pi by 4 is 1 by root 2. So you do the algebra. Finally, you are getting pi divided by 2 into root 2. Okay. Now, another relation, beta of x plus 1 comma y plus beta of x comma y plus 1. It should be equal to beta xy. So here let us use just the expression for beta in terms of gamma function. So it should be, what was the relation? Beta mn was equal to gamma m into gamma n divided by gamma m plus n. Your m is x plus 1 and n is y. So it should be, for this beta function, it should be gamma x plus 1 into gamma y divided by gamma x plus 1 plus y. And here it should be gamma x into gamma y plus 1 divided by gamma x plus y plus 1. So this could be our LCM. If you do this addition, in the LCM we have gamma x plus y plus 1, and here gamma x plus 1 into gamma y plus gamma x into gamma y plus 1. Now let us use the property for gamma n plus 1. Gamma n plus 1 means n into gamma n. So it should be x into gamma x, x into gamma x into gamma y. Here gamma x into, for this gamma y plus 1, it should be y into gamma y. So you see here which one is common? Gamma x into gamma y is common. So gamma x into gamma y into x plus y divided by x plus y plus 1. And again, you know, this gamma x plus y plus 1 will be equal to x plus y into gamma x plus y. Yes, so this x plus y from the upper side and the lower side will be cancelled. We have just gamma x into gamma y divided by gamma x plus y, which is nothing but beta xy. So you see, just using the relation between beta function and gamma function, this relation is very easily proved. Now, integration 0 to 1 log x with base e whole to the power 4. Here, if you substitute something for this log x, we could have e to the power something. That's why we this substitution is used. What is it? That is log x with base e equal to u. So x should be equal to e to the power u. You see, we are getting e to the power something. That means you can convert it. We can at least try to convert it for as an expression for gamma function of something. So here it becomes e to the power u. And now you take the differential, it will be dx equal to e to the power u du. And this becomes u to the power 4, right? Log x equal to u, so u to the power 4, and for dx, e to the power u du. Now adjust the limits. When x equal to 0, it should be infinity, because log of infinity, oh sorry, you know ln of 0 is minus infinity. Ln of 0 is minus infinity, and when x is 1, ln of 1 is 0. So minus infinity up to 0. This is the limit. Okay. Now let us have another substitution. Suppose, because you cannot use the definition of gamma function if the power of e is a negative number. Because what was the expression for gamma function definition? It was x to the power n minus 1 into e to the power minus x dx. So here, to use the definition of gamma function, the power of e must be something negative. So let us use this substitution, u equal to minus y. So du should be minus dy. So here e to the power minus y for du minus dy. Now adjust the limits. When u equal to 0, y should be 0. When u equal to infinity, minus infinity, y should be infinity. So the relation now becomes infinity to 0. Infinity to 0. And here, for u, it is minus y, but the power is 4. So ultimately, it becomes positive, and you adjust the limit with this minus sign. So now, we remove this minus sign by changing the limits, position of the limits. Now it becomes 0 to infinity. 0 to infinity, y to the power 4, e to the power minus y dy. And minus 1 whole to the power 4, it is 1. We just separate it, minus 1 whole to the power 4 into y to the power 4. And this is nothing but 1. So now it becomes 0 to infinity, y to the power 4, e to the power minus y. Then this 4 can be written as 5 minus 1. So now you can easily use the definition of gamma function. Our n is 5. So y to the power 5 minus 1 e to the power minus y dy is nothing but gamma 5. And gamma 5 means it is an integer. So it is factorial 4. So 4 into 3 into 2 into 1, which is 24. So x by ln x whole to the power 1/3. X to the power 1/3 into log x whole to the power minus 1/3. Here there is something. Okay. If you take log x equal to another variable, definitely there will be e to the power something. And we need a negative variable as a power of e. That's why we have taken log x equal to minus y. Because we need, if you do not take a negative variable here minus y, you should have another substitution, just like the previous one. Not this one here. Which one? Where we did another substitution. In which method? Okay, I think it was in the first page. No, where was it? We used another substitution with a negative number. Not here. lost it. Yes, here in this math, you see, here the substitution at first it was log x equal to u, not a negative variable, just log x equal to u. That's why we got something positive power here to e to the power. That's why we have to take another substitution, that is u equal to minus y. But if in the first substitution, if you put log x equal to minus u, I think then you would not need another substitution. So here in this math, from the very beginning, we have taken negative variable as a substitution for this math. You see, we are taking log x equal to minus y. So x should be equal to e to the power minus y. You see, here you are getting e to the power something negative. X equal to e to the power minus y. So dx should be minus e to the power minus y dy. Now adjust the limits. When x equal to 0, y should be infinity. Why? E to the power minus y means 1 by e to the power y. So it will be 0 if in the denominator we get 0. So that's why y must be infinity, because 1 over infinity is 0 and e to the power infinity is infinity. So when x equal to 0, y should be infinity. And when x equal to 1, x equal to 1, y should be 0, because you know that e to the power 0 equals to 1. Okay, so the limit now becomes infinity to 0. Infinity to 0. And for this x, we write e to the power minus y, and the power is again 1 over 3. So it should be e to the power minus y by 3. And this log x means minus y whole to the power minus y by 3, 1 over 3. And dx is minus e to the power minus y dy. Now let us do the simplification. Here, minus 1, we separate minus 1 and y. Minus 1 whole to the power minus 1 over 3. And under the integral, it should be y to the power minus 1 over 3 and e to the power minus y by 3 minus y. That means minus 4 by 3y. And this minus sign is adjusted with the limit. We removed this minus sign by changing the position of the limits. Now it becomes 0 to infinity and is adjusted with this minus sign. So here you are getting y to the power minus 1 over 3 e to the power minus 4 by 3y. Here, to use the definition of gamma function, here we should have e to the power minus just a variable. That's why we have taken another substitution, 4 by 3y equals to u, because in the definition of gamma function we have what? 0 to infinity x to the power n minus 1 into e to the power minus x, just minus x. So here this 4 by 3 into y should be taken as u. So 4 by 3 dy should be du. Let us put it here. And what about the limits? When y equal to 0, u is 0. When y is infinity, u is infinity. So no change in the limits. Y is 3 by 4 into u. Yes, 3 by 4 into u whole to the power minus 1 over 3 e to the power minus u, and dy is 3 by 4 du. Okay. So now this minus 1 whole to the power minus 1 over 3, it means 1 by minus 1 whole to the power 1 by 3. And this 3 by 4 whole to the power, there is another 3 by 4, so 3 by 4 whole to the power 1 minus 1 by 3, which gives you 2 by 3. And under the integral, it will be u to the power minus 1 by 3 into e to the power u. And this e to the power minus 1 by 3 can be written as 2 by 3 minus 1. Now it goes to the definition of gamma function. U to the power n minus 1 into e to the power minus u du. So it is gamma of 2 by 3, because here the value of n is 2 by 3. So ultimately this is your answer. There are complex roots there, but if you avoid to write down the complex roots, minus 1 whole to the power 1/3, it will be just minus sign, minus 1. So minus 3 by 4 whole to the power 2 by 3 into gamma 2 by 3. Just a minute, I'm coming. Integration 0 to 1 t to the power half into log of t whole to the power 1 by 5. In gamma function, beta function, there is no log. So we have to take a substitution for this log t. Definitely it is base, the base is not written here. It is implied the base will be e. Otherwise, you cannot use the differentiation formula. So suppose that here you see we are already taking a negative variable for this log t. So that you don't need to take another substitution to get a negative power for e. Anyway, so this substitution is taken here. Log t with base e equal to minus y. So t should be equal to e to the power minus y. So here in place of t, we will write e to the power minus y whole to the power half. And this log t is minus y whole to the power 1 by 4. And what should be our dt? dt should be minus e to the power minus y dy. Yes, minus e to the power minus y dy. Now adjust the limits. When t equal to 0, it is minus infinity, and minus minus cancel, so y should be infinity, plus infinity. And when t equal to 1, y should be 0. So the limit is from infinity to 0. Now, these two minus sign gives you plus sign, and e to the power, it should be minus y by 2. E to the power minus y by 2 minus y. Yes, minus y by 2 minus y, and here minus 1 whole to the power 1 by 5, and under the integral y to the power 1 by 5. So if you want to avoid the complex roots, the minus 1 whole to the power 1 by 5, it will be just minus 1. Integration 0 to infinity y to the power 1 by 5 e to the power minus 3 by 2y. Now try to write down the powers so that you can get gamma function. So this, oh no, you see there should be only one negative variable as a power to this e. So let us take another substitution. 3 by 2y equals to, say, x. 3 by 2 into y equal to x. So y should be 2 by 3 into x, and dy should be 2 by 3 dx. Okay, so here e to the power minus x, and in place of dy, you are getting 2 by 3 into dx. And in place of this y, we have to write 2 by 3 into x whole to the power 1 by 3. So outside the integral, 2 by 3 whole to the power y 6 by 5. Oh, there is another 2 by 3 whose power is 1. So 1 plus 1 over 5 is 6 by 5. And here the power of x is 1 by 5, and the power of e is minus 6. And this 1 over 5 can be written as 6 by 5 minus 1. So it goes to the formula 0 to infinity x to the power n minus 1 into e to the power minus x dx. So the value of n is 6 by 5. So it should be gamma 6 by 5. And here minus 1 whole to the power 1 by 5, 2 by 3 whole to the power 6 by 5. And for this integral, gamma 6 by 5. Okay. Now this one, there is a log x. So as before, we take this substitution log x equal to with base something negative variable. Log x with base e equal to minus y. So x should be equal to e to the power minus y. X equal to e to the power minus y. So dx should be minus e to the power minus y dy. Adjust the limits. When x equal to 0, log 0 is minus infinity. So minus minus cancel. Y should be infinity. And when x equal to 1, y is 0. So the limit is now changing. It is infinity to 0. Infinity to 0. And the value of x is e to the power minus y. So it should be e to the power minus y whole to the power m minus 1, that means e to the power minus y into m minus 1. In place of log x, we write minus y and the power is n. And in place of dx, we write minus e to the power minus y dy. Okay, now you do the algebra. Here, minus 1, if you separate this negative sign, it should be minus 1 whole to the power n, which is taken outside. We do not know the value of n, so we can write down the value. And this minus sign is adjusted with the limits. So 0 to infinity. Now what comes? Y to the power n, and what is the power of e? E to the power minus ym plus y minus y. So plus y minus y cancel out. We have y to the power n e to the power minus my. But to get that definition, to use the definition of gamma function, we have to take another substitution. Suppose my equal to u. So m into dy equals to du. When y equals to 0, u is 0. When y is infinity, u is infinity. No change in the limits. So it comes now y to the power n into e to the power, y means u by m. So u by m whole to the power n in y is du by m. So outside the integral, we have minus 1 whole to the power n divided by m to the power n plus 1. And under the integral, you have integration 0 to infinity u to the power n into e to the power minus u du. It is not now directly in the definition of gamma function. You have to get something minus 1. So we write it in this way: u to the power n plus 1 minus 1. N plus 1 minus 1. So in place of n, you have n plus 1. So the result should be gamma n plus 1. Anyway, this was the coming from the direct definition. Gamma n plus 1 was u to the power n, e to the power minus u. So this is the result. I think this is the last math. Integration minus 1 up to 1. 1 plus x whole to the power minus half into 1 minus x whole to the power minus 1 over 3 dx. Let us take 1 plus x equal to t square. Okay, this is totally different. Here we have 1 plus x and 1 minus x. Okay, if you take 1 plus x as t square, and it is 1 minus t square, so we should have another substitution with sine theta cos theta, right? Anyway, so you are taking here 1 plus x because, okay, you need a practice here, because if you do not know the type of substitution, you cannot do this math without any practice in your exam. So actually you need a good practice, because this is a totally new thing, very important function, beta function, gamma function. Please have a good practice on it. 1 plus x equal to t square. So x should be t square minus 1. If you take the differential, dx should be 2t dt. Now you adjust the limits. When x equal to minus 1 whole square is 1, so x should be 0. When x equal to plus 1, okay, I have to put it here. When x equal to plus 1, t square equal to 2. When x equal to plus 1, t square equal to 2. So t should be root over 2. And when x equal to minus 1, t should be 0. Okay, so your limit should be 0 to root 2. Yes, and here 1 plus x is t square. So t square whole to the power minus half. And here 1 minus x is t square minus 1, so it will be minus t square plus 1. Okay, so finally it becomes 2 minus t square, and the power is minus 1 by 3, and dx is 2t dt. So here the power becomes 2 into minus 1, that means just minus 1. Here t to the power minus 1 and then another plus 1. So it becomes 0, t to the power 0 is 1. So there remains only one factor, 2 minus t square whole to the power minus 1 over 3 dt. Now you take another substitution, this t equal to root 2 sine theta. Yes. T equal to root 2 sine theta, so dt should be root 2 cos theta d theta. Adjust the limits. When t equal to 0, theta should be 0. When t equal to root 2 sine theta equals to 1, so theta should be pi by 2. So now 2 into dt is root 2 cos theta d theta, 2 into root 2 outside. You take 2 common here, 2 minus 2 sine square theta whole to the power minus 1 by 3. So if you take 2 common, it will be 2 to the power minus 1 over 3. This goes outside the integral, and under the integral sign 0 to pi by 2, 1 minus sine square theta, it is cos square theta. Cos square theta whole to the power minus 1 by 3, that means cos to the power minus 2 by 3 theta. And there is another cos theta, so 1 minus 2 by 3, that means just 1/3. Just 1/3, cos to the power 1/3 theta. Here you can use Wallis formula, or the formula involving beta function, gamma function. Yes. What was the formula? Let us go back to the first page. Yes. Integration 0 to pi by 2 sine to the power p theta cos to the power q theta d theta equals to gamma p plus 1 by 2 into gamma q plus 1 by 2 divided by 2 into gamma p plus q plus 2 divided by 2. So let us use this formula here. Was here cos to the power 1 by 3 theta, just write the factor sign, so the power to this sign should be 0. Sine to the power 0 theta cos to the power 1/3 theta d theta. So here p is 0 and q is 1/3. So limit is 0 to pi by 2. So it should be gamma 0 plus 1 by 2, gamma 1 by 3 plus 1 by 2 divided by 2 into 0 plus 1 by 3 plus 2 divided by 2. Here it is gamma half, here it is gamma half, and here it should be gamma 4 by 3, again 2, so 4 by 6. Yes, gamma 4 by 6, and in the denominator it should be 5 by 3, no, 6 plus 1, 7 by 3 divided by 2, that means 7 by 6. Yes, 7 by 6. And here this is gamma half, means root over pi, 2 is here, it was in the outside of the integral, gamma 4 by 6 by gamma 7 by 6. Okay. Hmm. 4 by 6 means 2 by 3. So gamma 2 by 3 divided by this gamma 7 by 6 can be written as 1 by 6 into gamma 1 by 6, right? Now you just do the simple algebra, and this is your result. You know there is a list. There is a list for the values of gamma function and beta function. You know gamma half equals to root over pi, but you do not know the exact value of this gamma 2 by 3, gamma 1 by 6, etc. There is a list, just like the values of logarithm. There is a list for the results of gamma function and beta function in every book of mathematical methods. In every book of mathematical methods, in the appendix, you will always find a list of the results for beta function and gamma function. But for you, you can write your answer like this, no problem. You don't need to find the values of these gamma functions. Okay, our time is over, so let us end our class here. We will meet again tomorrow. Walaikum salam.